Today I'm going to be giving a presentation on the research that I did this year, optimized extractions of alkaloids from kratom and semisynthetic derivatives. This is the outline that I'll be using in this presentation. First, I'll give an introduction of kratom and its importance, and then I'll move on to the extraction and isolation of significant metabolites from the plant, and then lastly, I'll talk about the semisynthesis of metabolites of interest. The reliance on opiate for pain management has led to the current opiate epidemic that the country is facing. Pain affects over 100 million people in the USA every year, which reduces one's quality of life. One of the main targets of pain is the opioid receptors. There are three types of the opioid receptors, which are mu, kappa, and delta opioid receptors. The importance of these receptors is that they govern pain pathway, mood changes, and addiction. However, these receptors can also produce adverse side effects such as dependency, nausea, and respiratory depression. In recent years, the mu opioid receptors have been gaining popularity because they're involved in the pain pathway. Mitragyna speciosa, also known as kratom, is a psychoactive plant that is commonly used in Southeast Asia. The leaves of this plant is traditionally chewed or infused as a tea for the pain-relieving properties. As the plant travels around the world, especially in the United States, it is still used for pain but also for opioid withdrawal symptoms. Compared to other opioid drugs, there has not been any reports of casualty when an individual only consumes kratom. Mitragynine, the major component of the plant, is a partial agonist for the mu opioid receptor. As I said in the previous slide, mitragynine is the major component of the plant. Here I will discuss the recent study on the metabolism of mitragynine. Mitragynine is metabolized in the liver by cytochrome P453A4 in the liver into 7-hydroxymitragynine, which is 22-fold more potent than mitragynine. Then recent study also demonstrated that 7-hydroxymitragynine can be metabolized in the human plasma to mitragynine pseudoindoxole, which is 119 more potent than mitragynine. However, these metabolites are hard to isolate from biological sources and are produced in small amounts. For that reason, the necessity to obtain large amounts of material to be observed in biological assay is needed. Because of this, the aims of this project is for the extraction and isolation of mitragynine, and then use the isolated mitragynine to semisynthesize 7-hydroxymitragynine and mitragynine indole pseudoindoxole. Extractions of metabolites from the dried plant, we use acid-base extraction technique, where it is believed that when the organic compounds are acidified, the organic compounds are then moved to the aqueous layer, and when they're basified, we're able to collect the alkaloid fraction in a free base with chloroform. For the isolation, we use flash chromatography and HPLC to purify our compounds, and then we use mass spectrometry and NMR to confirm the identities of these compounds. After obtaining a large amount of mitragynine, we moved on to the semisynthesis of 7-hydroxymitragynine, where using mitragynine as a starting material, we were able to add a hydroxyl group with the use of oxone persulfate to semisynthesize 7-hydroxymitragynine with the yield of 45%. To semisynthesize mitragynine pseudoindoxole, the starting material that was used was 7-hydroxymitragynine, and with the use of zinc triphthalate and toluene, we were able to synthesize mitragynine pseudoindoxole with a yield of 44%. I have talked about kratom and its potential to be used as a therapeutic for pain. I've also talked about mitragynine, which is a major component of the plant, which has a partial agonist to the mu opioid receptor. We are also able to synthesize or semisynthesize 7-hydroxymitragynine and mitragynine pseudoindoxole. This work can work as a reference standard for other works. Also, due to the expensive nature and commercially unavailable the semi-synthesized derivatives are, obtaining methods to synthesize them can alleviate this issue. Thank you for listening to my presentation. I also want to give thanks to the Obike lab and the MARC program for their continued support throughout my time at UNCG, and now I'll be moving on to my graduate studies. Thank you.